So we know we have different types of tubes. And we know that depending on the type of tube that you have will kind of dictate what type of calculation you can do on that. And so that's going to drive what we're doing for this. Let me erase this here. And so what we have here, so I'm going to just kind of use this as an example. There are so many different things you can do. You can build a xylophone. There's ways to build a xylophone. You can build different types of flutes. You can build a pan flute that has lots of different tubes to it. You can build a regular flute that has a single tube to it, and you change on the where you play the notes. So there's lots of different ways you can do things. You can do something with a guitar. And again, if this were sort of full scale, all of those things would be options for what we're doing. For what we're going to do in class here, at home there's more options. So if for some reason you're not in class on Wednesday and you want to do one of the different options, you're welcome to do that. But in class we're going to focus on building a drum that's something like this. And so this one is not perfect. So when you hear it, you're going to be like, that is off key. Yes, it is. Many times these end up being a little bit off key, and that's okay. But in the end, you're going to play Mary Had a Little Lamb. So if you hear it on this one, sort of. Very off key. Hopefully yours is closer to that. But the biggest thing I want to show you with this is that each one of these is a different length and gives you a different sound. So if I tap here, I get a different sound than what I do when I tap here. And so all this is a PVC pipe cut to the specific length that we're trying to get to, and then having a little bit of duct tape over the top. So our goal then is to be able to build this and go from there. So what are we doing here? Well, anytime you hit something here, the frequency that you hear is dictated by n equals 1. So in all of the calculations that you'll do, you will use the n value of 1. That's the first step. In this situation, when we're dealing with a PVC pipe, and you're dealing with, so what we have is it's open on this end and it's closed on this end. So because it's closed on one end, we'll be using the equation that f of n equals nv over 4L. So if someone's not doing something that's closed at one end, if they're doing an open-ended flute where it's open at both ends, this would be a 2. What we're doing, because it's closed at one end, we'll be using a 4. N will equal 1. So anytime 1 times anything is going to keep consistent, so we can actually take this off. So we have f of n equals v over 4L. And in order to be really consistent, let me grab a thermometer. We're at 71 degrees Celsius in here. So what I'm going to do is, or sorry, not degrees Celsius, degree Fahrenheit, sorry. You can look online, and remember air temperature affects the speed of sound. And so we're going to get real specific. Speed of sound calculator. Temperature is 71 degrees Fahrenheit. And so the speed at 71 degrees Fahrenheit is 344 meters per second. So a lot of times we use 340. This is a little warmer than what we would use. So we're going to use 344 for our velocity here, because that deals with the temperature in this room. It'll keep it just a little bit closer, a little bit more precise. We need to solve for the length that we're going to be cutting here. So in order to get L to the other side, we'll do the opposite. Right now it's being divided. The opposite is multiplying. And then we need to bring the frequency over to the other side. We'll divide by f of n on both sides. So for us, I'm going to come up here. we have that the length will be equal to 344 meters per second divided by 4 times our frequency. Like that. So what we're going to be getting to is what length we'll need to cut a tube in order to get the correct sound based on different frequencies. If you have your iPad, please take it out and go to the stuff we have for this week. So pull up the assignment for the tubes. The Quarantine Instrument Project Summative. Or Quarantine Instrument Project 20, I think is what it's titled. Let me pull it up. And so I'm going to project it up here, but you're going to need it in front of you for what you'll be working on. And this is our one thing for this week. So last week we learned about how to calculate all of these. Now we're taking and applying it to what we are able to do with it. So it says that you'll choose one of the types, because we're building it in class and we're not going to be taking masks off, we're going to use the closed one end. Things that can work, bottles. When you blow across the top of the bottle and it makes a certain sound, that's setting up in the same way that we have here. PVC pipes, this is what we'll use. Again, we're not going to take masks off for this. Pringles cans work awesome. So if you happen to be home on Wednesday, you're like, oh, I don't know, oh, I've got some Pringles cans. They work really well. You just cut them to the length you need and boop, boop, boop. A pan flute works really well if you close the bottom. If you leave it open on the bottom, like you can use straws for it. If you leave it open on the bottom, you just don't get a very clear sound. If you close it up, you can get a clearer sound. Open on both ends if you decide to make a carrot flute or a straw instrument where you cut a triangle and it's like, and you cut it off at different lengths, so you can do something like that. So the different octaves, so in order to play Mary Had a Little Lamb, you have C, D, E, and G. And you can YouTube what notes you need for that. It starts with E, it goes E, B, C, D, whatever, and kind of goes back and forth there. And then once you have that, you need to figure out which octave it's going to be. The octave only changes kind of that total length that you'll need. So let's take and let's just do on the 5th octave, we're going to do 523 hertz. This would be the very longest tube you would need. So if we take and calculate this, we got to the equation that said L is equal to 344 divided by 4 f of n. So this is our f of n here. It's the frequency that we're playing where n equals 1. So if we put that in over here, we want to know the length. We have 344 divided by 4 times, my frequency here is 523.3 hertz. And that's going to be a C note. So 4 times 523.3 gives me 2093.2, so I'll take 344 divided by that. And I get a length of 0.1643. I'll round it there, meters, 164 meters. So the length of the tube that we would need to cut would be 0.164 meters for this one here. We bring that into centimeters, 16.4 centimeters. And so what I'll have in here on Wednesday is I'll have some pipe cutters. They're pretty easy to use. You tighten it up and swing it around, and tighten it up and swing it around. And it'll give you a nice clean cut on the pipe. And so 16.4 centimeters, that's not anything real big. If I take a ruler, maybe. So if I use a ruler here, 16.4 centimeters, I'd be cutting just right there on this pipe. So it's not anything super big. In fact, one of these might be 16.4. Yeah, it's not. That's why it doesn't sound so great. Oh, this one might be 8.2. Be half of that. Nope, not that either. Anyways, doesn't matter. And so depending on what the frequency is, will then depend on, it'll give us the length that we need. The thing that you'll need, you'll get one piece of pipe, and so you'll calculate, you'll do all of these, and you'll just have to make sure that they all fit. If this is too big, if the adding all of these up is too big, then go to the 6th octave. It'll actually cut those lengths in half. Does that make sense? So the 6th octave, actually for those of you in class here, might be a better option to start in the way of your calculations. The 5th octave will sound, it'll have a stronger sound because you just have more of a pipe there to produce it. The 6th octave will probably fit better in the lengths that we have to cut from. They're both gonna sound just fine with what we're doing. Let me just double check something here. 1, 5, 6, 8. Yeah, they get, the 6th octave ones get pretty small, so try, calculate maybe 5th and 6th, that shouldn't take too long to do. The thing is, when you actually build it, you'll need to make sure they're all in the same octave. So you can't be like, okay, I'm gonna use the 5th, C5 and D5, and then E and G from the 6th. That won't work. You're jumping too far on your octaves, so you're either doing this or this. So you can decide what you wanna do in those calculations. So, other ways that you can do this, open with one end, so you'll use this equation here, we talked about that at the beginning. You'll calculate, I would say try the 6th octave and see what you can do there. And then this is the page that you'll be submitting. You're gonna submit 2 things for this. The first thing is your page of calculations, the second thing is your video, and they're 2 separate assignments in Schoology for that. The video, you'll be able to, if you build it and make it in class on Wednesday, you'll be able to real quickly just do it in class. It's not something that you have to make a big production of. So you'll say what type of instrument you have, what octave you'll use, and then you'll show your calculations in here. So frequency, so what you'll do in here is to take these frequencies and you'll put them in here, C, D, E, and G. You'll do that. And then you'll show your calculation for each one, and then you'll write it in centimeters. After you've done that, then you'll build it. So for today, in the remaining time, we have about 20 minutes, take and calculate these. I'm not gonna hand out tubes until Wednesday, sorry. And then work on your calculations, get them double checked by me to make sure they're in good shape, and then you'll be ready to roll for Wednesday. Sound good? Alright, so go ahead and work on those. I'll be around to help. If you have questions, let me know. If you need a calculator, I have some. If you have a different idea of something else you want to do instead, if you're like, no, I really was hoping I could build XYZ, we can talk about it and make a plan. So, ready, set, go.